Hello everybody, welcome back to Advent of Code 2023. This time we will be solving day 16. The floor will be lava. So for this problem we have a map of empty spaces, mirrors and splitters, and our goal will be to find out how a light beam will spread from the top left corner of the map heading to the right. So what will happen if that we reach an empty space when the beam starts out, we will either hit an empty space, which means nothing, it just continues in the same direction. If we hit a mirror, then it's reflected 90 degrees perpendicular. Then we have our perpendicular like this, so like in 90 degrees basically. Then is if it hits pointy end of a splitter, it just goes through as if it was an empty space. And if it hits flat side of a splitter, it will split into two beams going each other in two different directions. And then that is it. Yeah, so essentially we are going to simulate that light beam going from that initial direction, and then we figure out how many tiles we hit during while that beam was moving. So we calculate the number of tiles, and then the number of tiles is the output of the problem. So it seems pretty reasonably easy, but it could be tricky. So let's see. Let's try it and we'll see. So I will do the sample input here and then do... actually I can take the same start as from day 14, because it's basically reading a map of width and height. So let's do that. So we have the map red. Now we need to have a we will have something like some method that will give us calculate energy, and it will start at source at a given position, int y, and then we will calculate that energy in there. So what we will need to have is maybe let's do also let's do an array of visited or energized, which will be a new boolean of width and height, and we will have so what we need to know when we're going through that space is that we can start with a source and then go forward. We can continue quite easily while we're at a single beam, but when we have multiple beams, we need to split and continue with multiple paths, and that would be still okay. But we need to make sure that we stop the computation when we get into a loop or cycle when we would go forward and forward. We need to make sure that when we visit the same tile in the same direction, we can stop, because we already went through that before. So what I will have to do also is a visited, which will be a new bool width, height and direction. It's gonna be a point essentially, but it's gonna be a direction in which we arrived in that point. So it's a type right. That's fine. Right. Okay, XY. Oh, right, of course. So it needs to be, we need to have, there are 4 different directions. So there are 4 different directions where we can reach that point. So we can use this, I think. Yeah. So we have a Q, which is gonna be a Q of int, and direction. Or we can actually do a hash. It's gonna be a new hash set of int point. That's more efficient, definitely. So like this, maybe. Yeah. So we kind of use that to see if we visited the same configuration, and the Q will be of that configuration as well. So it will be, or rather like this point. So yeah, position and direction. So again, position and direction. So now what we can do is enq, q, and q, new x, y, or rather like this. So enq xy and 0 or 1 0. So we go to the right, and missed 1 parenthesis. So now while q count is greater than 0, we do the following. So we start at this point in direction to the right. So we check if visited contains, state. So we dequeue the queue, check if the current state is already there, and if it's there, then we continue. If it's not there, we make sure that we add it to visit it. Then we energize that position. So we do current state equals true. So current state position x, current state position y. So we energize the position, and then we process. So for the new position, we calculate the next position. And so now if we need to check if we are outside of the array. So if new position x greater than width, greater than or equal to width, or new position x less than 0, or new position y greater than height, or new position y less than 0, then we continue. We cannot go there. And if it's not, then we can check if up new position. So how to call it, character. So we take the character that's there, and if the character is just a dot, then we are good. So we can do q and q new position direction. Else if if that character is equal to, so this mirror, then we have two options. So if you're going from the left, so if you're going from the left, you need to go up. If you're going from the up, if you're gonna go to the left. So if current state direction, so basically the x becomes minus y and y becomes x. So let's see, new direction. So it's gonna be, so if you're +1 to the right, we go up, so it's gonna be minus x, and y is 0, and like x is 1 and y is 0, and we so x becomes 0 now. So that's fine. From the up we are +1, 0 + 1, and we need to become 0 + 1, and we need to 0 + 1, and we need to become -1, 0. So like this might be okay. So let's see. If we're going from the right, we're going -1 for x, which becomes +1 and plus, yeah, this seems fine. So this should be it. So I think that is the correct approach. So enqueue, new position, new direction. If character is equal to \, we need to do a very similar thing, I think. What I've missed here, if, all right, I'm gonna type this. So if it's a \, we need to take the new direction and make it yx. Yeah, that makes sense. This is the opposite. And if the character is equal to this, so if we are going from horizontal, we just keep going. So if current state direction is 0, then we keep going, like we keep the same direction. So we enqueue new position with the same direction. And if we're going from the up or from the bottom, we need to split into 2. So it's gonna be new point -1, 0, or and 1, 0. So these are like split into 2 different directions. The same thing for this one. We split into, so if the y coordinate is 0, so we're going, oh right, I made a mistake here. So if y coordinate is 0 here, and if x coordinate is 0 here, then we need to do 0, -1, 1, 0, and then q. And then finally, when we're done with all this, we can return basically this. Yeah, count the number of locations which are energized, and then that should be it, hopefully. So let's see, console right line calculate energy, and let's see what happens. Right, 46. That is correct. So let's try on the big input. And let's hope it works out. 8,110. That is not correct. Okay, I made some mistake here. So what is there? So empty space is continuous. If it encounters splitter, passes through space, flat side of the splitter, split in two. So maybe I made a mistake with the mirrors there. So let's see. So if it's this is okay. This is okay. And let's see. $46 become okay. Right, so it doesn't immediately strike me as wrong, but maybe I made a mistake somewhere. So if we're going from 0, 1, 0, it should become 0, 1. That is correct. From minus 1, for 0, minus 1, it should become minus 1, 0. Yeah, that's fine. So what did I miss here? It runs more. At least one beam passes through it, reflecting it or splitting it. Yeah, that seems okay, but must have missed something here. So the source is top left corner, heading to the right. Empty space, it stays there. Top left heading right. So what is wrong here? If it's less than 0, we stop. That's okay. If it's greater than or greater than if, it stops. That's also fine. Must be some kind of mistake here. So if the current state direction has 0y, we continue in that same direction. Otherwise, it's split into two, -1 and 1, into two different directions. The same thing here if we are on the same, if we're going vertically, then we enqueue that. And if we are going Don't see the problem right now. I don't see it right now. So xy is 0, 0 initially. And the output is too high for a reason. Yeah. So what could be wrong here? Well, let's see. Initially the width and height is, what is the width and height? 110, 110, that's okay. Okay, the input reading is fine, right? So it's width, height, and then we read it into the map from the row, and it's, yeah, so that should be okay. So again, let's validate against the sample input. I must have missed something here. Something very basic. Let's maybe do for 0, just write what we have as the output. So y, x. Yeah, this looks okay. This looks exactly like what we have here. But what happens when we use the big input? I don't think we will be able to see anything useful there because it's just too large, but so apparently does the initial one count as well? Like, does it? Because if the initial one as well matters, then it could mean that like explain the problem that we are having here. So what I can try to do is adjust this code to work with the current position and the direction where I came into that position. So current state position X, current state position Y. So I could use the current state and then calculate the next based on that. Well, okay, well, this is going to be interesting. So maybe let's do it like this. So if if current state position X position X. So first off, we check if we are on a valid position. If not, we continue. Then we mark that position as visited. And then what we do is that we calculate the next new position by taking new direction, which is when it initializes this, and we just set that new direction. So new direction, we keep the current one. Then if it's this one, we do this. If it's this one, we do this. If it's, so essentially new direction equals this, and new direction equals like this, and again here same, and new. Okay, direction is this. So now right, there is multiple directions there. So yeah, okay, so Q and Q. So add NQ, I will do method NQ in that direction. So we NQ that point with that direction. So that should be it. So now NQ. So this will gonna be our helper method kind of to take care of this. So NQ and so on. So like this, like this, like this, like this. Also the same thing here, same thing here. It wasn't clear to me how the first initial step is done, but if it reflects immediately, it means that this should be the correct approach. So let's test this on the small sample. It should have the same output. 46, yes. So now let's try the big one. And it might be the right solution. Let's see. All right, and that is the right solution. So instead of what I expected, when we're standing on the mirror, we already reflect immediately, so it goes down instead of the right, which was the original solution. So now that we have the part 1, let's try the part 2. So now any edge tile and heading away from that edge. So we essentially can start on any location on the boundaries of the map. And we need to test whether it reaches how many tiles are energized, and we need to energize as many tiles as possible. So how many tiles are energized in the most potent one. So what I will do, it should be basically the same kind of calculation, just run multiple times. So what I will do is I will take our sample input again so that I can validate it. So let's put it here, and it should be 51. And what I can do is that I can go over the boundaries, and then I will also starting direction. So direction will be the initial direction. So direction here. And what I will do is calculate the maximum of this. So best will be 0 initially, and I will do for, no, not exactly this, but for x equals 0, x less than width, I will do math like best equals math max of best and calculate energy from x, y of 0 and direction of 0, 1. So we're starting to the down. Then also from height -1, starting to the top. And then for y equals 0, y less than height, we do the same thing essentially. So starting from 0 column, we go to the right, and then from the last to the left. And then if that's correct, then we should be able to output the best of those options. So let's run this. It should be 51, yes. And now the same thing for the big input, which could take a little bit longer, I think, but we'll see. It shouldn't be that major. And it's 8,335, which is correct. All right, so that is day 16 solved. It was a little bit tricky before I realized that the first initial tile also matters. So now finally we have the solution which is working, and we have solved day 16. Oh, the image is now starting to take shape. That's pretty nice. So I will see you in the day 17 videos, and also in the video where ChatGPT will try to solve this problem. And I'm not completely sure if it will be able to solve it properly. It seems that it could be something that's not really up to its liking, but we will see in that video. So thank you for joining this video. If you want to get notified about future videos, please subscribe and give me a thumbs up, and I will see you next time. Bye bye.